Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we took a look at Vertex buffer layouts and we designed a class that could handle all of that stuff kind of for us and elegantly so that it looked nice. Definitely make sure that you check out that video because I think it's really informative. I think a lot of people liked it as well. And it's definitely necessary for kind of what we're moving on with next, which is going to be talking about vertex arrays. And that's what we're going to do in this video today. So vertex arrays are essentially, in OpenGL, they're kind of defined as, they're a bit weird, to be honest. If I'm being completely honest with you, I don't really think they should exist. I do have a video covering vertex arrays in the OpenGL series, check that out. Again, just like with the previous video in this series, I don't want to just explain a lot of stuff that I've already explained in the past, so check out that video if you want more details. But essentially, vertex arrays are a kind of state-containing entity, right? So what they don't actually contain any real data. Like your vertex buffer is what contains your vertices. Your index buffer is what contains the indices. Those two pieces of kind of like, those two buffers are your actual buffers. They're memory buffers. They have your actual data. What the vertex array actually contains is just references essentially to a vertex buffer and to an index buffer. And also to something called a layout, which is of course what we talked about in the last episode. So basically what happens is you create a vertex array and then you can bind a vertex buffer to it and an index buffer to it. And those two kind of things, right, live inside that vertex array. Now it's important to note that when I say they live inside it, it doesn't mean that like literal copies of them kind of live inside. It's not that kind of living inside. What I'm actually talking about is the vertex array is associated with those two with the vertex buffer and the index buffer, but it's not actually like, it doesn't control its lifetime, right? And you know, if you like modify the vertex buffer itself, it's going to modify the same one that's inside the vertex array because the vertex array just has links. It's like kind of like pointers, right? They just have pointers to an existing vertex buffer and to an existing index buffer. They don't actually contain their own. They don't own the vertex buffer and the index buffer. They just kind of reference them, right? And then the other thing that it has is essentially all of the layout kind of information of our vertex buffer. So just like in the last episode, we talked about how we had to use vertex attribute pointers and we set up a buffer layout class and all of that kind of stuff, right? That is stored kind of per vertex buffer, as I said, but what happens is that state is stored in your array, in your vertex array, which means that when you rebind a vertex buffer, you don't need to redefine its layout unless it's changed, right? And this works a little bit differently for multiple vertex buffers because what you can do is you can actually have a vertex array and then have like several vertex buffers containing different information. Like you might have one for like positions, one for normals, one for bones, one for whatever it is that you're dealing with, right? And in that regard, they're still in the vertex array, but what you do is you actually bind the vertex array, bind the vertex buffer, set the layout for the vertex buffer, then you bind your next vertex buffer, set its layout with the vertex array still kind of bound, right? So you kind of just do it that way. But that's not something that we're really going to touch on today because using multiple vertex buffers isn't something that's very commonly done anyway, because it's usually better to just interleave all of your data in a single vertex buffer, which is what we've been doing. But that's kind of the gist of how it works. And with an index buffer as well, a vertex array does actually tie that in, which means basically that it also references that. So it's not just for vertex buffers and their corresponding layouts. It's also the case for index buffers, right? For element buffers. One other thing I want to mention is that there are some new functions in OpenGL 4.5 maybe. Not sure, I'll probably make an OpenGL series, like episode specifically about this anyway. But there are new functions to make this tying together a little bit more clear because it's completely it's messy, right? OpenGL's API in general is not that great. It definitely is a lot better with the introduction of these new functions. But basically, it just means that you can tie together like a vertex buffer or a layout or an index buffer or anything into a vertex array without having to bind a bunch of state. You actually just specify the ID of the array, the ID of the vertex buffer. It just kind of ties them together that way, which makes a lot more sense. Something that we might explore in the future, but I don't really want to restrict this stuff to, I guess, OpenGL 4.5, so to speak. It's not really something that I've explored myself yet. But I will probably make an OpenGL episode about that because I think that's worth kind of exploring. Anyway, let's jump in and take a look at how we can set up a vertex array class. Before we do that, one more thing that I want to say is that vertex arrays in general are not something that really exist in like DirectX. So the kind of the choice that we have to make here is how do we set this up in an abstract way, right? And as I said, right now this engine's focusing on OpenGL probably for quite a while, right? Because I would much rather get like, a full game engine kind of up and running using OpenGL first, right? And then start filtering in the other APIs, because this is going to take less time. It's going to just work better, and we're going to have an actual product to show a lot quicker than if we kind of try and just do all the APIs at once. So that's why for now, even though it kind of hurts me inside a little bit, I'm going to ignore DirectX and how DirectX deals with things. I mean, to a point, right? If it's an easy change, then I'm obviously going to make it. But something like this is not easy because it requires changing kind of a lot of the renderer API architecture, because it's like, obviously, if we mandate that you have to create vertex arrays and then a vertex buffer, for example, in your array, and that's not something DirectX has or needs, that's going to require some re-architecture to take place. Usually a quick fix is just basically having vertex arrays just do nothing in DirectX, right? So you can still create a vertex array in your kind of API, in your render API agnostic API, right? Which basically means that in our kind of Hazel render API, we can still create a vertex a vertex array. In OpenGL, it will create an actual vertex array. In DirectX, it can literally just do nothing. So that's one thing that you can do. And probably what we're going to do right now, because we need to get OpenGL to work. Anyway, let's dive in and take a look. Okay, so last time we had this triangle. We defined it by just kind of creating this layout here, right? So we had position and color over here. But the one thing that really kind of sucked for us was this kind of vertex array stuff was not abstracted whatsoever, right? And neither was this layout stuff. So that's kind of what we're going to try and do right now. We're going to create a vertex array. So over here in renderer, I'm going to make a new item. It's going to be a vertex array. And then, namespace Hazel. This is going to be it's going to kind of follow the same. I'm almost tempted to put it into buffer. The reason I didn't put it into buffer, the reason why I wanted it as a separate header file here and like a separate file, is just because it's going to be a little bit different. Let me just copy vertex buffer. It's going to be a little bit different because I'm not even sure if I want to keep it long term, or maybe we can call it something else. So I don't really want to kind of deal with that, I guess, for now. I don't even know what I'm including. Probably don't need much. I guess I'll include buffer. Renderer buffer.h. So for now, I'm kind of just keeping it separated because I'm not sure what its future is going to be. So we have a vertex array. We'll have a destructor. This is, again, the kind of platform, the render API agnostic like interface. In terms of creation, I think you can just create it like that. It doesn't really need any parameters. Set layout's not going to be a thing. What we can do is actually add a buffer to it. So add, I'm just thinking the best way to do this. We'll have add vertex buffer. So virtual void add vertex buffer, and then this will just take in a vertex buffer. Okay, so what we actually want to take in is a ref. I might talk about this in the future. For now, we're just going to take in a shared pointer. The way that resources are going to work inside Hazel is that basically every resource kind of related thing, like a vertex buffer, an index buffer, a texture, a shader, all that kind of stuff is going to be reference counted, right? So they're basically going to be shared pointers. Now, if I was really like pedantic and really specific about performance and all of that, I'd probably want to create an intrusive reference counting system. But I don't actually think shared pointer, especially if the actual reference count block is inline in memory, I don't actually think that it's going to perform worse. So for now, we're just going to deal with that, right? But we're going to just take in a const shared pointer, vertex buffer, and we'll just call this, I guess, vertex buffer, okay? And in the future, what we might do is just kind of, because the implementation might change and we don't want to change our code anywhere, I usually like basically changing the actual type name to be something else. but we will talk about that in another episode. So we'll have add the vertex buffer. We'll have can't even talk today. We'll have an index buffer as well. Add index buffer, which will take in an index buffer. We'll actually probably have, and we'll get rid of const here. We'll probably have some kind of like ownership actually taking place. We'll have bind and unbind. Now in the previous classes, we also have bind and unbind. It's not that necessary, but for vertex arrays, you actually kind of do want to unbind them potentially. Unless you like, it's again, as I said, it's good for testing, and I can kind of show you what I mean by that, maybe in another video if you're interested as to why on earth I write unbind everywhere. I mean, I don't write it in my code, but why the API supports it. But that might be something that we talk about later. We'll have to include memory as well to get access to shared pointer. Okay, cool. So there we have vertex array. Let's grab this file. Let's make a CPP file for it. Vertex array.cpp, and of course I made a typo. That's not my fault. I swear the letter R didn't punch in twice. We'll include the PCH and vertex array.h, namespace Hazel, and then we really just have the create function, of course. I'll copy and paste that, and we will copy and paste the implementation of this from buffer.cpp. So typical scenario here. Now, I have been using pointers up until now. Okay, so we could return a shared pointer here, and we could deal with refs, but obviously you can also return a raw pointer like this and then capture it into either a shared pointer or a unique pointer. So that's why for now, before we maybe switch to more of a ref system, as I said, because that's kind of where we're heading towards. If you want to do that yourself right now, you absolutely can. But because that's where we're heading towards, I'm not going to bother kind of changing that, I guess, now. So this will return an OpenGL vertex array. And that looks pretty good to me, I think. So now in platform OpenGL over here, I'm going to add OpenGL vertex array.h and OpenGL vertex array.cpp. This will include the PCH, not the handed coordinate system space, and the OpenGL vertex array header file, namespace Hazel. Okay, so include Hazel renderer vertex array. And then my typing right now is not that great. That's what happens when you try and do this kind of stuff in the morning. So let's go to our vertex array, I guess, and pretty much copy most of this. I'll just copy the whole class, to be honest. So this is going to be an OpenGL vertex array, which will be a vertex array. So what we're going to do is, so I'll just pop that in. Let's see. So we'll change this to say override for all of them. And then we've still got our bind and unbind, which is good. Okay, cool. And then we don't need create, obviously. So in terms of stuff that we're actually keeping, so we do actually want to have some kind of list, I guess, so a vector of shared pointer vertex buffer, okay? So we actually contain references to every vertex buffer that we actually put in. So just like OpenGL is doing internally, we're kind of mimicking or mirroring that on the CPU here by just having a list of all vertex buffers and index buffers. Don't believe you can have more than one index buffer, to be honest. I don't think I've ever done that before. So I might change this to set index buffer. I might be wrong. Maybe it's possible somehow, but to be honest, I've never seen it before. I've never done it before. So for now, we'll just call this set index buffer, and we'll just have one. So that behavior that I kind of described to you guys on how this works, you can see that we're kind of recreating it in code now, which is kind of the goal of all of this. So let's see what we have here. Nothing, which is good. I'm going to use Visual Assist here to just create all the method implementations. And here we have everything. So we obviously need to have a constructor as well. So let's just have a constructor. What's next? So in the constructor, we want to obviously create everything. If I look at just buffer, you can see that vertex buffer. Oh, sorry, GL buffer. You can see that we simply just create everything kind of here, right? I want to do the same thing with vertex arrays. So over here in my vertex array, I'm just going to call GL create vertex arrays. And then I guess I'll type in 1 and then the renderer ID. And what do we use for the renderer ID? Because I always forget, it's just a unsigned int. So as I said, we probably will end up like type defing that into something else. But for now, it's just that. Now that I seem to have gotten this wrong, maybe. So let's take a look at this. No, that's right. Maybe that's just not working because of me not including glad or something like that. Yep, okay, cool. So we can create a vertex array, and that's pretty much it. For binding, we just bind a vertex array. So GL bind vertex array, right? And it's just the renderer ID. For unbind, again, we just bind 0. For add vertex buffer, so what we need to do is actually make sure the array is bound. Now, I think someone asked the question of why I don't just call bind here like this. The reason I don't do that is because I don't generally like to like mix OpenGL calls with just my own calls. Obviously, in some situations, it's necessary if you're doing really complex stuff. But if it's just one line like this, I would much rather have it actually just be written here. And the reason for that is that like in the future, we might add stuff to bind, right? We might add stuff to unbind or whatever for like, tracking essentially or profiling purposes. I don't necessarily want this to register itself as an actual bind as if it's been called by the game or by the renderer, because this is kind of API internal things, right? So because this is API internal things, this is like totally fine to call. And I definitely don't want this function to start branching out into a bunch of other functions needlessly. If it's necessary, for sure, right? Like if I had a function called add vertex and index buffer, right? And it just did both, I'd definitely call this and this. I wouldn't copy and paste the whole OpenGL code there. But in this situation, it's just a simple bind. No need to just divert it into a different function and just complicate things by doing that essentially. Okay, so then once we've bound our vertex array, what we actually want to do is bind our vertex buffer. So in this case, of course, I will call vertex buffer bind because, this is dealing with an actual API object here. It's not dealing with its own kind of class. So I'm definitely not going to do anything like GL bind vertex buffer and then vertex buffer get renderer ID or something disgusting like that. So we're definitely going to bind it. Now what I need to do once I've bound it, if we go back to application, is I need to basically do all of this stuff. So pretty easy to do. I can just copy this code and paste it into here, right? Because that's kind of the idea. And vertex buffer's layout's going to get changed here. Now this shader type, again, at the moment, we're going to grab it and we're going to eventually might live inside some kind of OpenGL like shader class. But for now, we're just going to put it into the top of our vertex array over here, okay? And I'll make sure that that's tabbed across. All right, and that's it. That's literally all that we have to do. Obviously, I also want to actually add the vertex buffer to our list of vertex buffers. So I'll type in mvertexbuffers dot pushback vertex buffer, okay? And that will just add it to our list of vertex buffers. But that's it, right? If we suddenly decide that like that's fine, we want to add another like vertex buffer or something to this with a different layout, that's totally fine and it will work, okay? Just because we're doing it kind of this way. Okay, cool. And then at the end of this, it's not really necessary to unbind anything. I'm just thinking about this now. I don't think that we need to. Nothing's gonna go wrong. If you bind another vertex array before unbinding this, I think it's the actual binding that ties it together. See, this is why the API is terrible and that's why they changed it. But so I think it should be safe. I don't think suddenly it's going to belong to a different vertex array or anything like that. Here, again, we're going to copy this. This is really easy. It's basically just copying this, right? So we'll copy, that. And then instead of vertex buffer bind, we're doing index buffer bind, right? And then that's actually it, right? That's it. We don't need to do anything else. Like obviously we'll add it to we'll set it in our index buffer. I don't know why it's called index buffers, because it used to be a vector. We'll change that to index buffer. But that's it, right? This alone, binding it and then just binding the vertex array, then binding an index buffer associates it to the vertex array. I know it's crazy. I hate it. So does pretty much everyone else. That's why they kind of changed it or tried to make it. They didn't change it, but they made additional API so that you could write that code instead. That would be more readable, which we'll explore, as I said, in the future. But that's how OpenGL traditionally works. So there you go. Fun times. I think that should be it. So now let's take a look at what we can do inside our actual application class. So this is now gone, right? We'll keep this code because we're setting that up. This should be gone, right? And I think we also have a bind vertex array, yep, in the application, in the update or render, whatever the function's called, in the run loop, in the run function. So what we'll do is we'll go over here, we'll create and as I said, we're going to kind of get used to creating shared pointers, but until we have that properly set up, I kind of want to just stick with what we have here. So we'll create a vertex array. I'll put it up here because it's kind of the parent of these two. So we have a vertex array, which is a unique pointer just like everything else. We'll include that. And then we'll do vertex array.reset. And that's us simply creating it. If I can write the word create. So we've created it, that's done, right? Now what we need to do is, again, it doesn't really matter. We can create anything we want. We can bind anything we want. Now this is dangerous, and this is why I somewhat like unbinding, because if you leave this bound and you bind something else, which happens obviously when we create the vertex buffer, they're suddenly associated together. That's a little bit dangerous, okay? Because, you know, as I said, the thing that associates them together is just binding another vertex buffer while a vertex array is bound. That's kind of dangerous. I don't like that. Because as we said, you know, it's nice to just have, you know, we have a specific function here that we want to call, which is basically just saying that we want to add a vertex buffer to our vertex array, right? It's currently, okay, we will have to change everything to shared pointers, otherwise this isn't going to work very cleanly. So this could be a good time to do that. So this just becomes shared pointer. Nothing really changes, by the way. This just becomes shared pointer, and that's the only change, really. So what was I saying? Yeah, so if we do, if we add the vertex buffer, right? At this point, it binds the vertex array and the vertex buffer, and then thus that, you know, and sets the layout and links them together. But that's actually already happened. Why? Because we've created a vertex array, and obviously the create function for vertex array, as you can see, has bound it, right? It's done. Oh, actually, no, it hasn't, because we haven't called bind. That's interesting. So that might actually save us. But anyway, it does for vertex buffer, obviously, if we look at this, right? Because we have to upload the data. That's why. So, unless we unbind this, it's going to kind of bind itself to the vertex array. So that's kind of the situation that we're that we end up with, which is a little bit annoying because of OpenGL. But anyway, I'm going to not worry about any of that because I don't think that it's going to actually stop anything from working. I think that we might just be somewhat confused and end up kind of debugging the state of our application a bit more than we would otherwise if the API was better. It also means people might misuse this. It's hard for me to try and anticipate all the people misusing this, so I'll kind of leave it as is and see what happens. And based on the usage of this kind of API inside our engine, in the future, we may start unbinding things or dealing with some kind of different way of doing things. Anyway, so vertex array, we create the vertex array. It doesn't matter that we're doing it here, by the way, can be anywhere. We add the vertex buffer to the vertex array after it's been created and after we've set a layout, okay? So that's important, and we'll kind of get rid of that scope, I think. That's important that we do this after the layout has been set, because if we do it before, it's not going to do anything, right? Because you can see that here, it actually does this code, which depends on the layout. So that's important. If it has no layout or the layout is empty, well, you could assert over here and say that like there's no elements in the layout. In fact, that's probably something that I actually do want to do. So we'll say hz core assert, and we'll say basically that the vertex buffer layout get elements size, right? So basically the size of the elements has to not be 0, right? Otherwise, you could say that the vertex buffer has no layout. So we'll say vertex buffer has no layout, okay? And we'll put that as the very first thing in the function. All right, that's just a little guard in case, and we can test that out in a minute, in case you accidentally do that, because in that case, this won't work, even though the API might seem like it does. Okay, now again, what you could do to make that work, by the way, is you could, into the vertex buffer, you could add a reference to the vertex array the vertex buffer belongs to. So what I mean by that is when you add a vertex buffer, it just sets its parent essentially inside the vertex buffer itself. So this function just goes ahead and says, you know, you wouldn't pass it by const anymore, I guess. The function, this function goes ahead and just says vertex buffer dot vertex array or vertex buffer dot parent or whatever equals this. And that way it's got that connection. And then when you update the vertex buffer's layout, right, it can update the vertex array that it's part of, or vertex arrays that it's part of if it's multiple. So that's food for thought, but not something that I really want to do. And then finally we create our index buffer, and I also want to add that into here. Okay, cool. So add index buffer, index buffer. And that's totally not a thing because it's called set. Okay, cool. There we go. So now the idea is we can unbind everything. We can create a whole bunch of these, right? It's kind of hard to demonstrate in this one example just because it is so easy, I guess, or it is so simple in the sense that we're just creating one of everything. But if we had multiple, we could just go ahead and keep creating all of our other ones. Let's just say we're loading a bunch of meshes. We could, you know, create and load all of our meshes here. And then when we bind it, that's when it's actually going to kick in and use all the state that we've associated with it now. So over here, obviously, we're going to do vertex array dot bind, right? And then we're just going to render using draw elements, just like we have all of this time, right? Using the count from the index buffer. I think that is pretty much it. So we should be able to just run this code and hopefully it compiles and hopefully it runs as expected. No, it doesn't even compile. Okay, so vertex array redefinition, yep. That's because we used to have this unsigned int called vertex array. We can delete that now. Let's go ahead and try again. Okay, here's another error. Oh no, okay, we need to include Hazel platform. Is it not inside Hazel? Ah, it's just platform. I think I was surprised by that last time as well. Great, way to know your own code base, Cherno. F5, and what we should see is exactly the same result as last time, hopefully. Yep, cool, everything looks like it works. We could go ahead and just create another version, I guess, and see how that works. I guess I will go ahead and do that just quickly. So we'll try and create something completely different, I guess, to test this out. I said I would also test out the assert, so let's try and add the vertex buffer before we actually set the layout, see if it lets us without complaining. And you can see it doesn't. It says that vertex buffer has no layout, right? So it asserts, and then we're like, oh, we must not have set a layout yet for our vertex buffer. Okay, great. So let's go ahead and create maybe a square. So I'll basically need all three of these, right? Now, that's not technically true. Now I need the count, right? Because I need to know the count, the index buffer's count, right? That is something we could add to vertex arrays, right? Like deliberately like to the vertex array, because we don't have an API to retrieve what it stores at the moment. I'm gonna go ahead and add that though. So we'll say virtual std vector, std shared pointer, vertex buffer, right? There's gonna be a const and a const reference, get vertex buffers, const equals 0, all right? And we'll have the same thing, but not the vector, and that will be for our index buffer. So index buffer, get index buffer, right? And we'll copy this. We'll go into our OpenGL vertex array. And we'll just make these getters. Let me just move this out of the way. And this will just be this will just return vertex buffers, right? So we get the whole collection here, and this will return index buffer. Okay, cool. So now our API is capable of that, which is important because we're going to use it now. So over here, instead of creating like all, 3 of these, we can just say we want the vertex array, right? I'll call this something like square vertex array because this is our, I'll just call it square VA, square vertex array, right? This is going to be, we're going to make a square instead of a triangle here. So what we'll do is we'll kind of go over here. We've got the shader, maybe before the shader. I'll create this, right? So dot reset, and then vertex array create. I'll have to create a vertex buffer. So we'll say std shared pointer vertex buffer square VB equals std make shared vertex buffer, and then we'll have to take in the vertices. So we'll copy and paste these vertices. And what I want to do here is a little bit different than before because that's kind of the point of testing this. This is actually not going to have any vertex colors at all. Now this is going to be a little bit controversial because the shader actually expects vertex, it needs that color, right? You have to either use a different shader or whatever because otherwise it's just not going to work. So what we might do is just quickly create a new shader, or we can just go ahead and check to see, I guess, if that's been set or not, which might not be great though. We could add a uniform. There's a few things we could do, but we'll just see if it maybe renders a black square for us if we don't supply that vertex data, but it's a bit dodgy. You shouldn't be doing things like that. So maybe I'll just quickly copy and paste and make a new shader. I probably will do that actually. Let's copy and paste this shader quickly. And vertex source, 2, because I'm that imaginative, and also I just want to get this going. And this will just do that, and it will just have that. That's the only difference really. So we've got rid of v color, right? It's just got the attribute position, and then the color is just going to be set to I guess this, but we could set a flat color if we wanted to. Let's make it like blue, I guess. Okay, so this just sets it to blue. And we'll get rid of that as well. Okay, cool. And then this will be our second shader, mshader2. I hate this naming as much as you do, don't worry. We'll copy this, mshader2. I just can't, I'm sorry. We're gonna call it blue shader because I can't just call it that. Blue shader vertex source. I just remember that I have to push this to GitHub, so there's no way that I'm doing code with such bad naming. Be more descriptive. Use longer variable names if you have to. Trust me, it's the best way to go. Okay, so now we have 2 different things here as well. So this is just going to be, as I said, a square. So instead of doing all of this, we'll still have this at 0.5. We'll just adjust these vertices so that we're dealing with a square. That's going to be 3 times 4. And this will be negative on the x. Okay, that looks like a square to me. Good. Now we're going to create that vertex buffer, and just like we did with, we can't actually make it this way, by the way, because it doesn't have a constructor. So we can either just leave it like that and then reset it, or we can probably do make shared maybe with vertex buffer create, and then we'll have to put in the vertices, which are our square vertices, and then the size of them. So size of square vertices. Okay, and that should be okay. Great. So then we need to create a layout and set it and add it to the vertex buffer. The vertex array, just like here. So we'll say square VB layout, right? I mean, you could just put this right in here, by the way. If you really wanted to, you could just write code like this, right? And that would work. We might just do that just for fun so that you guys can see 2 different ways of doing it. But yeah, we can just set the layout to be that, which is also kind of makes it look really nice. Cool. And so there's our layout, and then we're adding it to the square VA, right? And what we're doing is the square VB, okay? Cool. So now we've basically transferred ownership into this vertex buffer because it's a shared pointer, and this scope will actually expire. but this variable rather in the scope will obviously end when the scope ends, but it still lives on inside our vertex buffer. Indices. So copy this, put it here. We'll call this square indices. We'll make 6 of them. 0, 1, 2, 2, 3, 0. Index buffer is going to be, we're just going to make a new one, right? So this is going to be the same as this, except IB and index buffer. We can just go ahead and do make shared, I guess. You can also do reset, as I said, but that requires 2 lines of code. So I guess we'll just do this. And we do index buffer create. This is going to be our square indices, of course. That looks pretty good. We might need another parenthesis. This needs to be an index buffer. Okay, cool. And then we just set the index buffer into our vertex array, obviously being the square VA. Okay, that's it. If we scroll down here, we can see how this works. So we'll still bind our shader. We can actually draw 2 at once. Might be weird. Maybe we'll draw the triangle on top of the square. So I might draw the square first. So we'll say square VA bind, right? We'll bind our square shader as well, or our blue shader. Bind, right? And then we'll do draw elements. We'll draw triangles. This will be a square VA, index buffer, get index buffer, get count. Okay. Then we bind the shader, vertex array, and then we just, do our triangle. So let's just see what happens here. Hopefully everything's going to work. I did kind of rush through this. Okay, we got a syntax error, I guess. Yep, I don't know why, but my parentheses are just leaving me. Vertex buffer can't instantiate an abstract class. Yeah, okay. I kind of thought that would happen, to be completely honest. It's because this is still a constructor. So I guess we can either set it directly, which should actually work if we just do that. Although I think maybe not. Yeah, this becomes a little bit, we will eventually return a, I would have thought make shared would have worked, but I don't want to deal with it right now. So we'll just do it this way. Eventually we'll return shared pointers instead of returning raw pointers. So it'll be fine. But yeah, we'll just do reset for now. Okay, cool, F5. All right, cool. So we have, it looks like it's still drawing 3 vertices, but it does look like it's drawing 2 things and with different shaders, which is nice. Now, why is it drawing 3 vertices? This definitely looks like it should have more than 3. Like as in we're setting square indices, like that's 6, right? Because there's 6 in here. And then over here, I thought we were getting the count out of this. So I'm suspicious now about our index buffer. So if we look at buffer, right, we have get count from GL index buffer, GL buffer. Get count just returns m count, and I guess we're setting that, right? Why wouldn't we be? M count is being set to count. That is quite strange. I wonder why we're only drawing that many. Quick way to check is just to make sure that we actually draw 6 by just calling 6 directly. And I might have to disable all the other stuff because this might not be working. Yep, okay, cool. So it's probably our layout that's actually wrong, unfortunately, because I was hoping that would just be a piece of cake. But that being said, I did rush through this, so who knows what kind of code I really wrote. And there's the problem. So we have index buffer being set into our square vertex array. That's actually the M index buffer, which is the index buffer with just 3 vertices. So make sure that we set the square IB, right? And then we can go down and actually change this back to being vertex, what was it? Square VA, get index buffer, dot get count, okay? F5, and now we should see both the square in the background and then the triangle in the foreground. And as you can see, that's what we get here. So they're the same size, which is why you see it like this. Let's make it a little bit more interesting and just make this maybe 7.5 instead of 5, just so that we kind of have it as a background and we have the triangle rendering in front and a little bit smaller. There we go. Okay, pretty cool. We have both of these things now rendering. one more thing that I want to do before we finish today is just clean up the code a bit. You'll notice that we don't actually need to have vertex buffer or index buffer here anymore. So I'm just going to delete both of these, right? So we kind of just have this and that. That's just going to mean that we're going to have to do a similar thing to what we did here, where we kind of created this stuff first. So we'll do, we'll just call this vertex buffer. So this will be kind of our plain example, I guess. And so we'll just quickly replace this. And then this, we'll do the same thing for here, which will just be index buffer. We'll call it index buffer. We'll do index buffer reset as usual and set buffer. Okay, there we go. F5, hopefully this all works. And we actually have some errors here. Let's see. And oh yeah, we use it here. So this obviously now just becomes m vertex array get index buffer get count. And I think that should be it. So let's just see what we get here. You can see it's working, which is great. Last thing I'll do to clean this up as well is we need to actually delete our vertex array. So I didn't add a destructor because I just had this thing here. So we will just copy this, go below the constructor, make this a function, and just call gl delete vertex arrays. Okay, and this will be 1 and m renderer id. M renderer id. Okay. Cool, just make sure that everything still works. And I think that's pretty much it. So hopefully this kind of helps you guys understand how vertex arrays work and how we're gonna use them. And now we kind of have almost enough code where we can actually not, write OpenGL code to make any of this stuff happen. And we can actually move this into the Sandbox app instead of actually having it inside application. The last piece of the puzzle is literally this draw elements. And we're gonna talk about that in the next episode. Okay, so I hope you guys enjoyed this episode. If you did, you can hit the like button. You can also help support the series by going over to patreon.com/the Cherno. Huge thank you, as always, to all the patrons that make this series possible. If you support the series, you'll get rewarded by you'll get certain rewards, such as getting access to the source code of my kind of private development repository of Hazel, where we've got like PBR rendering and just like a full 3D scene and a lot of really cool stuff that's kind of in development there. Next time, as I said, I want to talk about the renderer and how that plays a role and where that gl draw elements is going, because that's our actual draw command, that's our actual draw call. Yeah, we'll kind of move on with this and probably start kind of putting together like an actual 3D scene. I'll see you guys then. Goodbye.